start with a new topic, faces, edges and vertices. There is a cube given to us. We will see what are faces, edges and vertices of this cube. Solids are made up of polygonal regions called faces. So what are the polygonal regions of a cube? These are the square shaped polygons. These are known as faces. These are known as 1, 2, 3 and 4 and top and base. So there will be 6 faces. So solids which are made up of polygonal regions are called faces. Now the line segment which make the structure of the solid shapes are called edges. So the structure is formed by these line segments. These are faces. When two faces meet at a point and a line segment is formed, then that line segment is known as nothing but edges. Two faces meet at the edge of 3D shape. So these two faces are meeting at the point, that is line segment, that is edge. Here this and this face is meeting, so this will be the edge. And here this will be the edge, the where base and this one of the lateral surface is meeting, lateral face. And the edges meet at vertices, and many edges meet at a point, and that point is known as vertex, that is singular form, and vertices, number of vertex forms vertices. Okay, so the edges meet at vertices which are points. Such solids are called as polyhedrons. Such shape and such solid shape which are having faces, edges and vertices are known as polyhedrons. Example of the polyhedrons will be like this, triangular prism. Then here this is a brick. So these are all where the edges and faces are there. These are the faces and this is the edges, and these are the vertex that is meeting. Edges are meeting at a point. And these are the examples which are not polyhedrons. Why these are not polyhedrons? Let's see. Shapes whose all faces are not polygon. Their faces, they are not polygon, and which has one of the curved faces. This is a sphere, cylinder and a cone. Their lateral surface will be, one of the face will be curved. These are curved. So these are not polyhedrons. Now what are convex polyhedrons? If line segment formed by joining any two vertices of the polyhedron lies inside the figure. Line segment formed by joining any two vertices. So here I am taking a convex cube, and here vertex is this one and this is second point. If we try to join these two vertices, we are able to form a line segment, and that line segment will be inside the figure. Inside this figure we can see. So such polyhedrons are known as convex polyhedrons, where any two vertices will combine and inside and form a line segment. So that is convex polyhedrons. And these are the figures which are not convex polyhedrons, because their vertices meet, the line segment formed by the two vertices meet outside the figure. Like here is the vertex, here is one of the vertices. If we try to join the vertices, it will be meeting outside the figure. So it is not a convex polyhedrons. What are regular polyhedrons? A polyhedron is said to be regular if its faces are made up of regular polygons and same number of faces meet at each vertex. So here I have taken an example of a cube where the same number of faces are meeting to make each vertex, like 1, 2 and 3. 3 faces of this cube is meeting at a point to make one vertex, and here also 1, 2 and 3 faces are meeting at a point to make an vertex. So that is known as regular polyhedron, where same number of faces meet at each vertex. Now what will be not a regular polyhedron? So a polyhedron where the number of faces are different for each vertex. Like here at point vertex A, 3 faces of this triangle is meeting. So point A is made up of 3 faces, and on the other hand point vertex B is made up of 4 faces of this triangle, that is 1, 2, 3, 4. So this point, that is the same number of faces, it is not happening here. So this will not be considered a regular polyhedron. So this polyhedron is regular, this cube is regular, its faces are congruent, regular polygons, vertices are formed by same number of faces. And here this polyhedron is not regular, all sides are congruent, but vertices are not formed by same number of faces. As I told, vertex A is formed by 3 faces meet at A, and 1, 2, 3 and 4 faces meet at B. So these are the regular polyhedron and this is not a regular polyhedron. Now what is prism? A prism is a polyhedron whose base and top are congruent. So here the base, this is the base and this is the top. These two will be congruent in a prism, and whose other faces, that is lateral faces, that is the faces which are connected to the base, these are the faces, so that are lateral faces are parallelograms in shape. So there will be two conditions for prism, where the base and top will be congruent and the lateral face are parallelogram. Here it is a parallel shape. Rectangle can also be known as a parallelogram, where the opposite sides are parallel and equal. So these type of shapes are known as prism. Here also you can see this is a parallelogram, and the base and the top are congruent polygons. Now what is a pyramid? A pyramid is a polyhedron whose base is a polygon and whose lateral faces are triangles with a common vertex. So pyramid will be, base is polygon, so any polygonal shape will be at the base. Here it is a rectangle and here there is a triangle, and whose lateral faces, so these are the lateral faces are triangles. So this will be triangle, all these shapes will be triangle, faces will be triangle with a common vertex, and the vertex will be common here. This is the vertex. So such shapes are, solid shapes are known as pyramid. Now next is Euler's formula. What is Euler's formula? Euler's formula shows the relationship between edges, faces and vertices of a polyhedron. So it shows the relation between these three things, that is faces, vertices and edges. Faces is denoted by F, V is vertices and E are the number of edges. So formula is F plus V minus E is equal to 2. So that is Euler's formula. And how we can apply this, let's see with an example. So let's explain this Euler's formula with an example. I have taken a cube here. So first we have to find out the number of faces here. So what are the number of faces? We have earlier also said that 1, 2, 3, backside 3 and 4, and top and base will be added 2. So total will be 6 faces there in a cube. Now vertices. What number of vertices? 1, 2, 3, 4, 5, 6, 7 and 8. Total 8 vertices. What are vertices? Vertices are where the edges are meeting. And now what are the edges? Edges are the line segment where the two faces are meeting. So first we will take the edges of the top. That is 1, 2, 3, 4. The 4 will be at the top. So 4 will be at the bottom also because it is congruent. The 4 plus 4, 8. And 4 at the lateral faces. That is 1, 2, 3 and 4. The total there will be 12 edges. Now according to Euler's formula, that is F plus V minus E is equal to 2. So let's take the RHS side. Let's take the RHS side. What is RHS side? F plus V minus E. So F we have got 6 plus vertices are 8 minus 12. So 6 plus 8 is 14. 14 minus 12, that is equal to 2. Okay. So we this is equal to the LHS side. Sorry, this is LHS and this is equal to the RHS side. So like this we can say that Euler's formula is proved. So this is, the cube will be considered as a polyhedron